Hey y'all. Uh, so we're taking a look at the course content for week 2, and this is morbidity, which is of course a fancy word for illness, and we're going to talk about calculating incidence and prevalence rates, which are pretty straightforward. I'll allow you to read through this on your own. Again, it's just a in-depth explanation of what we mean by morbidity. So we're going to start talking about incidence rates. So the difference between incidence and prevalence is that incidence is the number of new cases. Okay, so whenever you see new cases of disease, you know automatically that that's incidence rates. Okay, so obviously when we're talking about this, what we're talking about is the number of people in a given population that are affected by a disease or infected with a disease. And this is how we calculate it out. So you might want to write down this formula. Pretty straightforward. Number of new cases divided by the population at mid-year. And the reason that we use the population at mid-year is because the population tends to fluctuate from the beginning of the year to the end of the year. So just to kind of average it out, they'll take the population at mid-year. All right, so total number of new cases divided by the population. So we're talking about, let's say, Philadelphia. The population of Philly is 1.5 million and some change, and the number of new cases of TB was 340. And then it says the rate was 340, or excuse me, the number of cases was 340. The rate per 1,000 persons would be 340 divided by the population, and then you multiply that number by 1,000, and you get 0.22. All right, now they should tell you, or I should tell you on the test, what you want to calculate the rate out to be, whether it's 1,000 or 10,000 or 100,000. And whatever you're calculating out the rate to be, whether it's 1,000 or 10,000 or 100,000, that's what you're going to multiply it by. Okay, so if you're calculating out the rate to be per 100,000, it would be 340 divided by 1.5 12684, and then multiply that by 100,000. And basically what you're looking for is an answer to kind of make sense. So if you look at that first one, 340 divided by the population times 1,000, and you get 0.22 per 1,000. So the way that is interpreted is that for every 1,000 people, pardon me, 0.22 will be infected with tuberculosis. So that doesn't make it's kind of hard to picture, right? So the one for 10,000 makes a little bit more sense. So for every 10,000 people, 2.24 people are infected. So about 2 people are infected out of every 10,000. Okay, for every 100,000, it would be, I guess we move it over, 1? So 22 people for every 100,000. Okay, so let's take a look at an example. All right, so we have the population of Philly, and we're told that males make up 48% of the population. And then we're given something like this, and we're going to see something like very similar to this on our test. So what you're going to do here, and I have another document uploaded under this week's course material. It's a supplement to this PowerPoint presentation, but basically what you're going to do is, take this number 1.1419440, and then we want to calculate out each one of the ethnic groups. So the African American group, the white group, the Latino group, and so on and so forth. So it's pretty straightforward. 0.48 to find African Americans, 0.48 times 1419440. And that's why I have this supplement posted here. So this is the numbers that were given. And I just calculated some of these out for us. Okay, so if let me see if I can get this one here right. So if for the African, I didn't calculate all these out. I just stuck with the African Americans, and you can calculate the rest of these out. So males make up males make up 48% of the population. African Americans make up 48% of the population. So again, same number there. Male African Americans are 48% of this 681,331, and then females are 52% of this 681,331. Okay, so Now we have the total number of male African Americans and the total number of female African Americans. All right, so from then, and you can go through these and calculate out the rest of these numbers for these different ethnic groups. Um, um, so next thing we want to do is we're given the number of new cases of tuberculosis for each one of these groups. Um, we're told that there are 135 African Americans, there are 105 male African Americans, and 30 female African Americans that have all been infected with tuberculosis. All right, so we have the number of new cases, and we have the number of people within each one of those groups. So it's very important when you're calculating these out to make sure that we use the correct numerator and the correct denominator. So if we're calculating out the incidence rate for male African Americans, we want to make sure that that denominator is going to be the population of male African Americans. All right, so incidence rate for African Americans, 135 divided by the population, 681,331. And we're calculating this out by 10,000, and we get 1.98 per 10,000. So for every 10,000 African Americans, almost 2 of them will be infected with tuberculosis. For the male African Americans, 105 new cases divided by the population, which we have right here, 327,039, and then we multiply that by 10,000, and we come up with 3.21 per 10,000. And this last line you'll see has a typo. I apologize about that. 30 African American females that are infected with tuberculosis out of 354,292 total female African Americans. And so we do that division and then multiply that. That's supposed to say 10,000. I'm sorry about that. I accidentally put 100,000. But it would come out to be 0.85 per 10,000. Okay. So again, these are pretty straightforward. Try these. I'm going to go through another example of the of an incidence rate here in a minute. And then with prevalence rate, it's essentially the same exact thing. It's just that rather than new cases, you're looking at the number of existing cases. So that's just the difference between incidence and prevalence. Usually prevalence is going to be much higher than the incidence, since the total prevalence is going to be the total number of people that have the disease, and the incidence is the people that were newly diagnosed with the disease. But the calculation is exactly the same. It's the number of people infected divided by the population. And then you multiply it by, either 10,000 or 100,000, whatever the problem asks you for. Okay, so let's take a look at another example here. And again, this is going to be something that is very similar to what is on our test for this week. All right, so we're given a population, 2,600,000 people. We're told that males make up 48% of the population, so that comes out to 1,248,000. Females make up 52% of the population. So the numbers in bold here are numbers that I had to calculate out. I just, for interest of time, I just filled this out already for us. But on the test, you will have to calculate out those numbers. Okay. And then it tells us what the city ethnic racial makeup is. 42% African American, 40% Caucasian, 50% Latino, and 3% Asian American. And then the subsequent calculations are already completed. Okay, so we have total population for the city, and then the total population of males, total population of females, total population of African Americans, Caucasians, Latinos, and Asian Americans. All right, so this is one of the problems. This is one of the I think it's the last problem on the test. All right, so let's say that we have 25,000 new cases of chlamydia. 85% of the cases are female, and that comes out to be 21,250. 15% are male, 3,750. 60% are African American, so that comes out to be 15,000. And then 15% are Asian American. Again, 3,750. Okay, so what is the incident rate per 100,000 people for the city? All right, so when you're talking about the whole city, the whole population, 25,000 new cases of chlamydia. We're given the population as 2,600,000. So it's simply 25,000 divided by 2,600,000. So why don't we do this? 25,000 divided by 2,600,000 equals, and then we're going to multiply that by 100,000. And our number comes out to be 961. Since we're talking about human subjects, it's probably a good idea to round off. Actually, let me correct that. Since this is a rate, it's probably best to leave it at 1 decimal point. I won't take off as long as the calculation is correct. So we just have to remember to write that in there. Okay, so the final rate is 961.5 per 100,000 people. So for every 100,000 people in this city, 961.5 will have chlamydia. All right, so incidence rate for females. All right, so cases of females, 21,250, and divided by what is the population of females again in this city? 1,352,000. 1,352, and then we're going to multiply that by 100,000. All right. Divided by 1,352, and then multiply that by 100,000. And we have a rate of 1571.7 per 100. Okay, so what you might be asking is why is the rate of how can the rate of females, the rate in the females, be higher than the rate for the city? And just remember that the rate, 85% of the cases are female. All right, and only so 15% are male. So there's a much higher rate of this in the female population. So population in the entire city, what is it? Almost half the population is male. So that actually does make sense, even though the number seems much higher, or it is much higher than the city. So you can figure it out for the males. I'm going to skip down to let's do the Asian Americans. All right. So total number of cases in the Asian American group, 3,750 divided by the population of Asian Americans, 78,000. And we're going to multiply that by 100,000. All right. Uh, 4807.7. Okay, so for every 10,000 people, or excuse me, for every 100,000 people, that's a pretty high rate. 4,807 of them are going to have be infected with what were we talking about? Chlamydia. Sorry about that. Okay, so where I see people make mistakes is that they use the wrong denominator. They use the total population for the city rather than the population for that specific ethnic group. Okay, so just make sure that you match the correct numerator with the correct denominator. Okay, and I think there was one more thing that I wanted to take a look at here, if I can find it. Well, here's the test for this week, so I might as well take a brief look at this. All right, so again, starts out pretty much, sorry about that. So starts out pretty much the same as the problem that we just took a look at. Gives us the population of Philly, tells us males, the male and the female population, population for the ethnic racial group, or excuse me, the ethnic racial makeup. So calculate out all these populations. This zip code 19133, that's West Philadelphia. So you can calculate these out, but you're actually not going to use these for the rest of the test. And then this information here is actually also additional information that we're not really going to need for the rest of the test. All right. So the first problem, pretty straightforward. Incidence. It tells us what the incidence. I forget what we're talking about. Gonorrhea. So the incidence or the number of new cases of gonorrhea in 2005 were already given population of Philly in 2005. Right. So pretty straightforward calculation there. This is a chart. Gives us the number of cases for each one of these ethnic groups. Again, we've already calculated out on the first page the ethnic racial makeup for each one of these groups. Okay, so pretty straightforward calculations there. And then it asks us, so this chart asks us to fill it out per 100,000. And then down here, you're also calculating out per 1,000 and per 100. So it's going to be the same number, basically. The decimal point is just going to be moved over, right? And then this is the case, or excuse me, this is the problem that we just pretty much just took a look at, okay? It's the numbers are all different, that's all, okay? So I don't specify here to calculate it out per 100,000. So I'd recommend using 100,000 though, okay? And that's pretty much it. We're going to talk about the epidemiological triad in another video. Okay? All right. And I think that was all I wanted to talk about. All right. I hope this was helpful. Thanks.